At 5:36 a.m. on February 17, 2025, the bustling metropolis of Delhi stirred from its slumber, not to the familiar cacophony of urban life, but to an unsettling tremor that shook buildings and rattled nerves. A magnitude 4 earthquake, originating near Daulakwan, rippled through the city, jolting residents awake and sending a stark reminder of nature's raw power. While Delhi fortunately escaped without casualties or significant damage, the event served as a potent wake-up call, compelling us to examine the city's vulnerability to seismic activity. This was no ordinary morning jolt. The quake, though moderate in magnitude, was the strongest to hit Delhi in at least 5 years. It served as a stark reminder that even a city not traditionally considered earthquake-prone is not immune to the Earth's restless movements. The incident has sparked discussions and debates, urging citizens and experts alike to delve deeper into the science behind these tremors and assess the potential risk they pose to the capital. The Delhi earthquake, though a relatively minor event in seismological terms, has thrust the issue of earthquake preparedness into the spotlight. As we navigate the aftermath of this tremor, we are left with a lingering question. How prepared is Delhi to face a more significant seismic event? Delhi's position on the Indian subcontinent places it in a seismically active region. Though not as prone to high-magnitude earthquakes as the Himalayan belt further north, Delhi is categorized as Zone 4 on India's earthquake hazard map. This classification signifies a high-damage risk zone, highlighting the city's vulnerability to significant shaking during a moderate to large earthquake. The city's vulnerability is further compounded by its dense population, aging infrastructure, and rapid urbanization. The potential for widespread damage and disruption in the event of a major earthquake is a serious concern. The recent tremor, therefore, serves as a timely reminder of the need for robust disaster preparedness and mitigation strategies. The recent earthquake, however, has underscored the need for greater public awareness about earthquake preparedness. Knowing how to react during and after a tremor can significantly reduce risks and save lives. The Delhi government, in collaboration with disaster management agencies, is stepping up efforts to educate the public on safety measures and response protocols. Central to understanding Delhi's earthquake activity is the Aravalli-Delhi Fold Belt, a geological feature that runs through the city. This ancient fold belt, formed millions of years ago, consists of deformed rock layers that bear witness to the immense forces that shape the Indian subcontinent. While the Aravalli Range itself is considered relatively stable, the fault lines and weak zones within this fold belt can still be sources of seismic activity. As the Indian tectonic plate continues to drift northward, colliding with the Eurasian plate, stress accumulates along these ancient fault lines. The recent earthquake in Delhi is likely a result of this ongoing tectonic activity, a release of pent-up energy along one of these weak zones within the Aravalli-Delhi Fold Belt. The presence of the Aravalli-Delhi Fold Belt makes Delhi susceptible to a specific type of earthquake, intraplate earthquakes, unlike the more powerful interplate earthquakes that occur at plate boundaries like the Himalayas. Intraplate earthquakes originate within a tectonic plate. While generally less intense, they can still cause significant damage, especially in densely populated areas with vulnerable infrastructure. Section 4. Delhi versus Himalayas, a tale of two quake zones. While both Delhi and the Himalayan region experience earthquakes, the underlying geological mechanisms and the nature of seismic activity differ significantly. The Himalayas are located at the convergent boundary of the Indian and Eurasian tectonic plates. The ongoing collision of these massive plates is the primary driver of earthquakes in the region, resulting in frequent and often high-magnitude tremors. In contrast, Delhi's seismic activity is primarily attributed to the reactivation of ancient fault lines within the Aravalli-Delhi Fold Belt. These intraplate earthquakes, though generally smaller in magnitude than those in the Himalayas, can still pose a significant threat due to the city's high population density and the vulnerability of its infrastructure. The recent earthquake in Delhi serves as a stark reminder that seismic activity is not limited to regions conventionally perceived as high risk. Understanding the distinct geological characteristics and earthquake mechanisms of different regions is crucial for effective risk assessment and mitigation efforts. Section 5, Echoes of the Past, Delhi's Seismic History. Delhi's tryst with earthquakes is not a recent phenomenon. Historical records suggest that the city has experienced several tremors in the past, some even causing significant damage. One notable example is the earthquake of 1720, which is believed to have caused widespread destruction in the city. However, due to the limited availability of detailed historical data, the exact magnitude and epicenter of this earthquake remain uncertain. Another significant earthquake that impacted Delhi occurred in 1803, damaging the iconic Qutub Minar. Initially attributed to a local fault, recent research suggests that this earthquake likely originated in the Srinagar-Devrayag region of Uttarakhand, highlighting the far-reaching impact of Himalayan earthquakes. Examining historical earthquake records is crucial for understanding the seismic hazard potential of a region. By analyzing past events, scientists can identify patterns, assess the recurrence intervals of earthquakes, and improve future risk assessments. The historical earthquakes that have impacted Delhi serve as a reminder of the city's vulnerability and underscore the importance of preparedness. Section 6. The sounds of stress unraveling the quake's auditory mystery. A peculiar phenomenon reported by many residents during the recent Delhi earthquake was a rumbling sound accompanying the tremors. While often misinterpreted as buildings creaking or objects vibrating, this auditory experience is a genuine seismic phenomenon. Earthquakes can generate low-frequency sound waves that travel through the earth and are sometimes audible to humans. These sounds, often described as a rumbling, roaring, or booming, result from the rapid release of energy during an earthquake. The vibrations travel through the ground and are transmitted into the air, creating audible sound waves. The specific characteristics of the sound, such as its frequency and loudness, depend on factors like the earthquake's magnitude, depth, and the local geology. The experience of hearing sounds during an earthquake, though unsettling, is not uncommon. Understanding the science behind this phenomenon can help alleviate fear and prevent misinterpretations. Public awareness campaigns that include information about earthquake sounds can contribute to a more informed and prepared citizenry.